The runoff curve number method is a procedure for hydrologic abstraction developed by the USDA Natural Resources Conservation Service in 1954. In this method, runoff depth is a function of total rainfall depth and an abstraction parameter referred to as curve number, or CN. The curve number varies in the range 1 to 100, being a function of the following runoff producing properties of the catchment: hydrologic soil type, land use and treatment, ground surface hydrologic condition, antecedent soil moisture. The curve number method was developed based on 24-hour rainfall runoff data. It limits itself to the calculation of runoff depth and does not explicitly take into account temporal variations of rainfall intensity. The temporal rainfall distribution is introduced at a later stage during the calculation of the flood hydrograph by means of unit hydrograph convolution. Potential runoff, that is, total rainfall, is referred to as P, and actual runoff as Q, with P greater than or equal to Q. The actual retention is P minus Q. The method defines a potential retention, or potential maximum retention, S, with S greater than or equal to P minus Q. The curve number method assumes a proportionality of retention and runoff, such that the ratio of actual retention, P minus Q, to potential retention, S, is equal to the ratio of actual runoff, Q, to potential runoff, P. This equation was developed by Victor Ponce in the 1950s. The runoff curve number equation is essentially a nonlinear fit to the rainfall runoff data. The use of a parameter, potential maximum retention, underscores the conceptual basis of the method. The method defines an initial abstraction I sub A as the amount of rainfall below which runoff is zero. To account for initial abstraction, the curve number equation is modified to solving for Q, which is physically subject to the restriction P greater than or equal to I sub A. This equation has two parameters, S and I sub A. To simplify the equation and enhance its practical utility, NRCS expressed the initial abstraction as a function of the potential retention as follows. This equation was developed based on rainfall runoff data from small experimental watersheds. The coefficient 0.2 has been subjected to wide scrutiny. Data has shown that this coefficient is likely to vary between 0 and 0.26. However, 0.2 is the standard initial abstraction coefficient recommended by NRCS. The standard runoff curve number equation is which is physically subject to the restriction P greater than or equal to 0.2S. For research applications, particularly when warranted by field data, the standard 0.2 value can be relaxed. In this case, with K equal initial abstraction parameter. Ponce expressed the potential retention S in terms of a surrogate parameter referred to as the curve number Cn, varying in the range 1 to 100 as follows. such that for Cn equal 1, it follows that S is equal to 990 inches, an extremely large and for practical purposes unreachable value of potential retention. Conversely, for Cn equal 100, it follows that S is equal to 0, clearly the lower bound for potential retention. In terms of Cn, the standard runoff curve number equation is which is physically subject to the restriction P greater than or equal 200 over Cn minus 2. In this equation, P and Q are given in inches. In SI units, the equation is which is physically subject to the restriction P greater than or equal R times 200 over Cn minus 2. With R equal 2.54 centimeters per inch, P and Q are given in centimeters. With R equal 25.4 millimeters per inch, P and Q are given in millimeters.